Good morning to everyone, or good afternoon, or good evening. Let's restart our solar energy session with two excellent speeches today. First of all, we would like to have your permission to make an inversion in the order of the presentation as indicated in the program. As decided between the two speaks and following the tradition of kindness, ladies will be first. So the first in charge today is the renewable consultant Aniella Descalzi, and the second one will be the professor Iniyan from Anna University. So we will have two continents' point of view enriching our panel today. My name is Eliabe Ricard. I'm a renewable energy researcher in the Energy Planning Department at Federal University of Rio, Brazil, and I will be here to mediate the conversations. We all know that among our listeners there are other experts, and I thank you in advance for your participation. And as well, I invite all of those who attended this presentation to participate with your questions and comments, thus brightening up this event. Each speaker will have 20 minutes to explain their ideas, and only after the two lectures in sequence, we will have the space for questions. Therefore, we encourage you to type your questions in the chat at any time, indicating which of the two speakers the question is driven to. Well, without wish to spend more time that should be dedicated to presentation and discussions, I present to you the consultant Aniella Descalzi, a renewable energy consultant. As said, Aniella, you will have exactly 20 minutes, being able to complement by answering the questions that will be addressed to you, okay? I will make you know when missing 5 minutes to the end of your time. Miss Aniella Descalzi is very welcome. This channel is yours for the next 20 minutes. Please.
Thank you very much for your kind introduction, and thank you very much also PAT 100 and UFRJ for the invite. It's an honor for me to participate and share this panel jointly with the Dr. Iniyan and you, Eliab. I don't know if I have the control of the PPT of the map. Yes, I have it. So I need the pointer option here. Just 1 second. I'm going to let's see if working. Just 1 second. Okay, perfect. So, well, on this time, I'm going to present an overview of solar power in Latin America. I know that the audience is from India, Russia, and different countries, so I think it's proper to do and to present the macroeconomics and especially the political context in Latin American region. Also, I'm going to do a brief description of the energy demand and Latin American energy matrix. I'm going to talk about the Latin American countries leading the energy market, Brazil, Chile, and Mexico. Then I'm going to talk about the different mechanisms are boosting the solar energy in our region, talking about the regulation as a key of deployment of the power in the region, the solar power in the region. And I'm going to finalize with the future of solar with the Brazilian and Chilean cases. Sorry, I'm going to turn off my camera because it distracts me a little bit. And I think it's interesting to see the graphs and information on the presentation. Latin America is composed by 21 countries. In the north, here is Mexico. Here is Central America, composed by 7 countries: Guatemala, Belize, El Salvador, Honduras, Nicaragua, Costa Rica, and Panama. And here is South America, composed with Venezuela, Guyana, French Guiana, Suriname. Here, the biggest country is Brazil, Colombia, Ecuador, Peru, Bolivia, Chile, Argentina, Paraguay, and Uruguay. According with the World Bank data, Latin America has 646 million of population, a territory of 20.4 million of square kilometers, and 5.7 trillion of dollars of GDP. That means the 6% of the global GDP. In reference to the political context in Latin America, we saw last year that Ecuador, Bolivia, and Chile were dominated by political crisis and social protest against the governments. The past 25 of October, a few weeks ago, 78% of the Chilean population voted in a plebiscite for a new constitution. Venezuela is currently dealing with the most serious crisis in the region, and Argentina is characterized for an economical recession. In Central America, the cases of Guatemala, Nicaragua, and Honduras present problematic scenarios in terms of stability and democratic governance. Bolsonaro's election after corruption scandal, Lava Jato, in Brazil is also an expression of a polarized country with no clear direction. The panorama in Mexico is also uncertain, and I'm going to finalize with the presidential impeachment in Peru 2 days ago. Despite of this uncertain political context, I have to inform that that historically the region is characterized by a robust growth in demand, as you can see in this chart. According to the World Bank Energy Report, per capita consumption will increase from 2,115 kilowatt hour per year in 2016 to 6,150 kilowatt hour per year in 2050, which is equivalent to more than 3 times the current level. Regarding to the annual growth rates, energy consumption in Latin America will have 4.9% between 2016 and 2035, and going growth in 2.4% between 2035 and 2050. Regarding to the installed capacity in the region, and as we can see in this graph, the installed capacity in 2019 was around 420 gigawatts, 45% hydroelectricity, 15% renewable energies, mainly biomass, solar and wind, and 21% of gas and other thermal. And the projection of the different expansion plan in the region is that the capacity by 2030 in Latin America will increase in 600, I think it's 90, I cannot see the number here, gigawatts, and 52% of this capacity will be renewable energy, going growth mainly in wind and solar, and just the 12% of the installed capacity will be hydroelectricity. We can see clear decrease in the hydropower and a significant increase of renewable energy in this chart. Well, moving now to solar, okay, and after making a brief description of the political situation, energy demand, energy offer, and also macroeconomics in the region, the Latin American region has an excellent solar resource, as you can see in this map of global horizontal irradiation. The north of Chile here in Atacama Desert has one of the highest radiation in the world. We can also see that the global horizontal irradiation in Mexico is very high. And on this area of Brazil, where it's located the northeast of Brazil, is also very good radiation. In fact, Brazil, Chile, and Mexico are the three countries leading the solar market in Latin America. And despite of all the uncertain and political problems, issues that I mentioned before, the solar energy market are being strong and growing fast, even during the pandemics. Well, if we review the numbers, okay, it's important to mention, I'm going first to talk about Mexico. So the total installed capacity of solar power in Mexico is 4.7 gigawatts. It means 6.4% of the Mexican electroenergetic matrix, plus close to 1 gigawatt of the distributed generation installed. The case of Chile, we have that 3.1 gigawatt of solar power installed capacity connected into the Chilean interconnected system that correspond to 12.6% of the Chilean electroenergetic matrix, plus around 700 megawatt of the DG installed. The case of Brazil is a bit different because if you see the numbers here, the capacity of the distributed generation is higher than the capacity into the interconnected system. So Brazil has 2.9 gigawatts of solar power connected into the interconnected system that represent 1.8% of the Brazilian electroenergetic matrix, and also there are 4 gigawatts of the DG capacity. So in addition to the excellent radiation, these three countries have something in common. The regulation related to solar power have boosted the solar industry, generating millions of jobs, access to energy, competitive and cheaper price of energy, and reducing emissions. Well, the first case I would like to show is the case of Chile, because Chile is a country that has more mechanism to promote solar energy between the three countries. So if we can see in the chart in the left, we can see the growth of solar capacity in Chile in megawatts, and the different mechanisms that have promoted the solar power. The first mechanism I would like to highlight is the quota mechanism. The quota start the law in 2008 with the law 20,257. Okay, when first generation companies sell a minimum percentage of renewable energy, okay, and was updated with with biggest percentage in 2013. Also, the other mechanism I would like to highlight is the public auction. Chile has public auctions since 2006, but they only incorporating solar and not capacity, just energy public auction in 2015. So I think that was the main driver, because if you see this chart, after 2015, in 2016 and 17, the growth is very significantly. Chile also comes with a special GD policy for projects with capacity less than 9 megawatts, with the instrument DS244 in 2005, replaced it in this year with the Supreme Decree DS88. The other mechanism important to mention is the private or corporate PPAs. Is a contract between the generator and the big consumer in order to have secure the finance of the solar project. The last mechanism that Chile have is the net billing law for the residential and smallest projects. Okay, the case of Brazil, the mechanism that have promoted the solar power public auction as well from 2004, incorporating solar in 2007. Brazil has a very mature free market, so a small consumer can choose for renewable energy as well. Sorry, can you hear me? Because my computer is telling me that I have connection problems.
It's okay. I'm listening to you.
Okay, thank you very much. And the GD policy in Brazil for projects with capacity with less than 5 megawatt AC is the normative resolution 482 in 2012, replaced it or updated in 2015, and it's amazing and impressive the growth of solar capacity in Brazil since this policy. So Brazil today has around 7 gigawatt of installed capacity between DG projects and utility scale projects. And also important to mention that Brazil currently has subsidies regarding to the renewable or alternative sources, in particular solar, with a discount of 50% of the rate of use of the transmission or distribution system. And the last example is in Mexico. So the mechanism that have promoted solar energy in Mexico are the public auctions in 2015. And we can see since 2017 and 2018 and 19, the significant and the clear growth in the solar capacity in Mexico. And also Mexico has a very good GD policy, Ley de la Industria Eléctrica. And if you want to read more, you can find an LIE in 2018. It's important to mention as well that the auction prices in the solar power in dollars per megawatt hour, and in the case of Brazil, okay, is continuously decreasing. Also in Mexico and in Chile. Okay, and I'm sure that the auction are the powerful energy mechanism attracting investment and allows to increase competition in the generation market. And according to OLADE and Global Wind Energy Council, the auctions have boosted 80% of the renewable energy capacity in Latin America. So I think that we have to focus in this kind of instrument, and it's important to know the last prices of the public auctions in the different countries.
5 minutes.
Thank you very much. Well, finalizing the future of solar power in Brazil, as you can see in this chart, you can see in blue here, hydro installed capacity will decrease in percentage significantly, and also the wind and solar capacity going to increase, and the forecast or the expectation by 2050 that the solar capacity in Brazil will be around 70 gigawatt of installed capacity. So it's growing a lot. The same case in Chile, we have the same behavior that in Chile, the hydroelectricity is decreasing in the percentage in the time, and we can see a clear and impressive increase of the solar capacity in Chile by 2050. Okay, so to finish, I just would like to highlight 5 points. One is that political context in Latin American region is uncertain, but solar market always are growing. Latin America is a region with excellent tradition. Electrical institutions in the region are very solid and robust and strong. Public action have strongly boosted the solar energy market, and the future of solar power in the region or the future of power in the region will be mainly solar. So I think that it's all by my side, and I comply with the 20 minutes.
Okay, thank you very much, the engineer Aniella Descalzi, for sharing her work with us with so many updated information. We will continue to discuss soon in the question session. Okay, thank you so much again. At this time, we invite the Professor Iniyan from Anna University from India. Professor Iniyan, we are honored with your participation, and the channel will be also yours for the next 20 minutes. I will make you know when missing 5 minutes to the end of your time, okay? And you'll be able to complement your presentation by answering the questions that will be driven to you in the end of the session, okay? Professor Iniyan, welcome.
Yeah, so I'm going to make the presentation in the recent trends in solar energy technologies. And when you look at this, the first slide, and you can see the lot of solar PV panels upon the canal. So in the canal, the water is flowing, and from one end to the another end. And this is covered with the solar panel. This is in one of the states in India, in Gujarat, it is being installed. And as we all know, and when the temperature increases upon the solar PV panel, the efficiency will decrease. And since it is covering the canal, and since the water is flowing at the bottom, and the temperature of the panel is reduced, and by which the efficiency is better. And that is interesting part. And apart from that, it gives very good say aesthetic view in the city. Something about our city and about Chennai in India, and this is our famous dancing, and these are some temple. This is a beautiful seashore. It is one of the second longest beach in Chennai. And these are all some interesting monuments. So we welcome you to Chennai to visit all these things. So this is Anna University is one of the oldest engineering institution in India. It's a AD 1794. Over 225 years back, the institute was started by the Britishers. And we have all the engineering programs, including architecture and various technologies. And so the outline of my presentation is solar energy scenario in India, and then solar energy resource assessment in India, and then research and development in solar thermal and solar photovoltaic energy systems at Anna University in Chennai. And so initially I talk about energy scenario in India. And when we look at the say in the world map, so India is here. It is one of the Asian countries, and here we have about more than 300 sunny days in the year we have. And the solar radiation may be in the range of 4 to 6 kilowatt hour per square meter in a day. This is very good, and the intensity is very good, and the number of days also very good. So we have plenty of solar energy in the country. And okay, so this is about the renewable energy installed power capacity. And here, when you look at the solar energy part, so we have installed so far 35 gigawatt. And so then followed by wind energy about 37 gigawatt, and then small hydro 4 gigawatt, biomass about 10 gigawatt, and overall about 88 gigawatt only from renewables. And this is about the state-wise estimated solar power potential, and these are the various states in the country. And when you look at the solar potential, we have about approximately 750 gigawatt potential we have in the country. And this is about the Ministry of New and Renewable Energy. So we have separate cabinet ministry to promote renewable energy in the country. So the target says by the year 2022, and 175 gigawatt has to be installed. So that is a huge target. So through entire renewable energy, it is about 175 gigawatt by the year 2022. And this is about the growth of solar capacity in India. So when you look at that, till 2010, it was not much growth. And then the solar mission was started by the central government of India. And then if you look at that, so, and it is growing steadily. And then from 2015 onwards, so you can find some rapid growth. And now we reached about 35 gigawatt of electricity through solar itself. And so that is about scenario. Then when we come to solar resource assessment, and so here this is about say India solar resource, that is direct normal irradiance, and you can see the picture here, and here you can see the global horizontal irradiance, that is annual average. So we have enormous amount of potential and throughout the country, and except northern side, and it is Himalayan region. So apart from that, we have say solar energy throughout the country. And this is about the installation of say instruments to measure the solar radiation in the country. And so I mean, so we have installed a lot of weathering stations, and then we have created the solar atlas for the entire country. And also it is also being disseminated, and the industries, so they refer the solar atlas and finding out say solar irradiation in various places. And this is about the say meteorological tower. So you can see this is say, and this kind of weathering monitoring stations are being installed in many places in the country. And here you find say ultrasonic wind sensor, and then GPS here, and rain gauge, and then temperature and sensor and data logging system, and of course the battery is also there, and it is supported by the solar PV panel. And this kind of, and here you find say the pyranometer and pyroliometer to measure the direct radiation and global radiation. And this kind of setup is there in many parts of the country. And we have say in the first phase they install about 51 stations, and then 60 stations, and like that there are about 121 stations installed across the country. All this dot represents this solar radiation resource assessment stations. And so the data will be coming to the central point that is there in Chennai, and each and every minute, so the complete data will be coming and storing in the data logging system. The temperature, even the wind velocity, and the radiation, and say the humidity, everything will be say recorded every day, every minute. And this is some advanced station, that is SRRA, that is that measurement stations, and it is about say a couple of stations are there, and considering I mean having say sun photometer, and so to measure the wavelengths, and UV rays and IR spectral analysis. So these are all some special stations which will say I mean consider even the suspended particles and everything. And then coming to research and development activities about solar thermal technologies in Anna University. And here you see the hot water from Parabolic Trough Collector for requirement of tribal community in the welfare. And see here it is it's a governmental project received by Anna University. Of course, I'm the principal investigator for this. And you can find the Parabolic Trough Collector, and of course these glasses, of course it is imported from Germany, and so it has absorber tube, and you have the you can see the panels here, and here it gives the temperature of close to boiling temperature, and then it comes to the tank, and the tribal people, so they take hot water, and for the cooking as well as for the bathing. It is in the hill station and above sea level, and always so cold temperature during the night. So they take a lot of hot water for the domestic purposes. And here again, so this is the boiled water. They come in order, and they fill the vessels and then take home. And every day it happens, and about 1,000 liters being produced every day for these tribal people in the hill station. And this is the performance of the collector, and say about the temperature. The inlet temperature of the water and outlet temperature and storage tank temperature, thermal energy output. So everything is being recorded, and each hour it is being recorded and it is maintained. And this is about the monthly performance, about how much CO2 can be saved and what would be the energy output, and what is the average direct normal irradiance and electricity consumption, and for the motor and other things. And these are all recorded every day, every hour it is being recorded, and the monthly performance is being shown here. And this is about the yearly performance of the system, and of course it is there in the detail. And okay, so this is the this here, and the thermal efficiency is being enhanced with the expensive passive multiple porous insert is being given in the absorber tube, and optical efficiency is also enhanced by the secondary reflector, and the reduction of CO2 emission is being taking place at an average of 1 ton per month. And next technology is being developed in Anna University. This is about the water desalination from solar energy, and these are some brief introduction about the importance of the desalination all over the world. Say the fresh water is really needed, and in future there will be some shortage for the fresh water, and we can utilize the solar energy technology and to get the fresh water. And here you find so there are various tests are being done, and this is the normal solar still, and the main problem with solar, we cannot get solar energy during night time. So we have some thermal energy storage material here, that is the phase change material. Paraffin is used in this system, so even the night time, so the solar energy is stored in the daytime through PCM material, and nighttime it emits the heat to the surrounding water, and then it gets evaporated, and then it gets condensed, and we get desalinated water. And so another kind of experiment, and we have used some titanium oxide, that we mix the nanoparticles with the paraffin material, and by which the thermal conductivity is increased, and by which the yield is also improved. And then we also used with the storage material with the copper oxide. It's another material that is and even by which the yield is improved. And here it's another material. So we tested with a lot of nanoparticles, and so it gives very good yield. And these are the various systems here. And so this is just with the PCM material, and this is PCM1 and PCM2 and PCM3. That is various nanoparticles are mixed with the PCM material. And these are some inferences here and here. And when we use PCM material, the yield is also increased. When we mix nanoparticles with the PCM material, it is further increased because the heat conductivity is better. So And so we checked with various nanoparticles, and the copper oxide is giving very good result out of this. And the water quality test also being conducted, and so after the desalination, it's good. So the before desalination, and this is the pH value, and after desalination, and this is a desirable limit. So, and everything is within the limit, and fall below with the desirable limit, and so after the desalination, really it gives very good fresh water. And this is a basic type of solar cooker, and in the solar cooker we have a lot of problems because it's not at being commercialized, because nighttime we cannot use it, and the people are not interested to go to the terrace and do the cooking, and we cannot go for the deep frying. So these are the main problems with the solar cooker. So that's why we have developed, say we have a lot of reflectors here, and by which the timing could be reduced. So normally just to boil the rice, it takes at least 1.5 hours in the normal solar cooker, and with this we can minimize the time. Within 45 minutes we can finish it off. But
5 minutes, Professor.
Yeah, and when we come here, there's a parabolic trough collector for the cooking, and so we allow the terminal fluid, and it gets heated up, and we use the thermal storage here, and oil gets heated up, and the night time we use the hot oil for the cooking purpose. So that is wonderful. And see this is the PCM balls. We insert the paraffin material, and daytime it absorbs heat energy, and nighttime it emits, and nighttime cooking also possible. And since the furnace oil, the terminal oil is heated up, and even the deep frying is also possible. And these are the specs of the parabolic trough collector. And this is the spec of the terminal oil and demannitol PCM material. And this is some experimental step setup. The spec is given here, and then how to encapsulate the PCM material and inside the balls. Okay, and then this is another technology. It's a cold storage application. So we use the solar energy through solar water heating system. So we use vapor absorption system, and we give the heat energy through say hot water that is from solar energy, and say instead of using electricity we use solar energy in the vapor absorption system, and for the cooling purpose. And this is the chiller. It's a big setup, and again we are using the solar energy, and it's a vapor absorption system, and we use heat energy and for the generator from water heating system. And this is about the other activity about solar PVT collector. So the PVT collector, in the top layer you have the PV panel, and bottom we are sending the water, and the PV panel gets cooled up. Because of that the efficiency is improved, and since it takes the hot say heat from the panel, and we get ultimately the hot water. So, and it's a hybrid system. We can get hot water, we can also generate electricity. The performance is also improved a lot. This is the performance graph, and when we cool the panel the efficiency is enhanced, and of course we get also hot water as the byproduct. These are some inferences. Improvement is about 14% about the PV panel performance. Okay, and this is about the again it's a collaboration with Australian National University, and this is about the concentrating photovoltaic thermal collector. This is absorber tube, and here we have attached the solar PV system in the absorber tube, and because of the concentration the efficiency is improved. And to cool down the PV cell we allow the hot water, allow the water, it becomes hot water. Again it's a hybrid system. And finally this is about solar photovoltaic unit integrated with the free cool thermal energy storage system. And here so the PV panel is getting say the temperature is removed by sending the air. So when we cool down the PV, definitely say the performance is improved. Of course we get the hot wear, ultimately then it can be utilized for some other purpose. So with this I stop, and thank you for your listening.
Perfect. Thank you so much, Professor Iniyan, for the excellent speech. Let me see. Just 1 minute. We have some questions, and I'm trying to organization it. Perfect. Many thanks to Professor Iniyan for his rich presentation. For sure, 20 minutes of each participant, it's very few for so much information that they carry with them. But without delay, we will pass to the questions and answers stage. Remember that all questions will be properly addressed to each speaker. And if those we cannot read the question here in public for the reasons of time, of course, that one who wish to formulate new question to speak outside this panel, we encourage you to do it, going in contact with them. Okay. The first question is addressed to Ms. Aniella Descalzi, and I will join two questions, engineer. The first one, can Aniella comment on how can solar provide auxiliary services and help the grid with the integration of large amounts of renewable? And I think it's in the same field. I would like to put the second question to you. Why is there is only solar photovoltaic in our region? Did you understand? It's clear?
Yes.
Okay.
Can you hear
please.
me?
Yes, I can. The word is yours.
Thank you very much. Thank you very much for the questions. I'm going to reply first the question of the ancillary services. In fact, the solar farm property of First Solar Luz del Norte, located in Chile, is commercially bringing ancillary services into the electrical grid. So the question is how the ancillary services is AGC, and I can send to you the report later if you send them an email or LinkedIn message of the report made by the Coordinador Eléctrico Nacional and First Solar. The Coordinador Eléctrico Nacional is the national operator in Chile, because it's very interesting. It's with a lot of details, and I strongly recommend to read this report, because it's the first solar farm bringing ancillary services. And in fact, I think 2 days ago, the First Solar award something and mentioned in one interview. So it's I think it's innovation, it's technology, and solar power can bring ancillary services. The second question, let me see, it's in the chat or not? Okay, are there specific financial mechanism for solar power in Chile? Well, I mentioned it in the presentation about a specific mechanism, regulatory mechanism, okay, but not financial mechanism like subsidies. There are not subsidies in Chile for solar energy. So the market of the generation market in Chile and Brazil, also in Mexico, is a competitive market. So there are not a special financial mechanism for solar energy in utility scale and also DG projects. Maybe you can find something, subsidies in solar and the residential solar farms, but in general, not. There are specific regulations are helping, are boosting the solar energy market, but not a specific financial mechanism.
Thank you so much. I would like to extend the question to Professor Iniyan as well. Okay, Professor, are there specific financial mechanisms for solar power in India? And a second question too, okay? Could you give us a general view concerning the renewable technology made in India?
Yeah, the renewable energy technologies really it is picking up, and so in the country already the renewable energy is contributing about 25% of share in the total energy scenario. Yes, and as I said, I mean through solar PV we have installed about 35 gigawatt, and from wind about say 37 gigawatt. And overall, so we have installed about say 88 gigawatt, and yeah, it is really picking up. And so the target is there about 175 gigawatt by the year 2022. Of course, it is a huge target. I think the government is working on that. Yeah.
Eliab, you are muted.
Okay, I'll talk to myself. Sorry for that. Okay, let's go. Okay. There's questions going to Miss Aniella, and after we will have another question to the Professor Iniyan. Miss Aniella, in your opinion, what will happen to energy bidding due the pandemic? En español, ¿cómo van las licitaciones por la COVID-19?
Sorry, I didn't understand your question. A ver. Well, let's see the chat.
What will happen?
Financial.
What will happen with the energy bidding for the reasons of the pandemic?
Okay, understood. Sorry. I have problems with my internet. It's a bit weak today. Well, yeah. I'm going to mention the three countries I presented before. And the last auction or bidding in Brazil was in 2019, considering solar, and the auctions are postponed or cancelled. And during this year, I think the next auction will be in 2021. The case of Chile, the last auction was in 2018, and the next will be probably in 2021. And the case of Mexico is uncertain because of the uncertainty in the politics of this country. So, well, during the pandemics, the solar market are growing in construction, but the main mechanism are postponed.
Okay, thank you so much. We have two more questions to Professor Iniyan. The first one, is there some special training for the people to use solar heating? Use electricity, it's easier, but heat may mean some training and people have to be convinced to use it. Can you comment, Professor?
Yeah, of course, we have some training program, and if on solar photovoltaic systems, and for the technicians, for the electricians, and we give a training program. There is the Ministry for Skill Development. So, and lots of training programs are being conducted, and awareness programs also being conducted, and to promote renewable energy in India. Yes.
Okay, thank you. The second question to you again is, does floating solar PV have better efficiency than the panel installed on the ground?
No, and of course it has to be inclined according to the latitude, and each place is having its own latitude. For example, Chennai in India, we have 13 degrees latitude, and it has to be inclined. And of course, it has to face the south direction. Then only it will give the better performance. And yeah, of course, we can install it in the land, but then we have to keep it the proper latitude and proper angle, as well as it has to face south direction according to our region.
Okay, thank you. And the last question is going to Miss Aniella. We talked so much about the frame of the solar power in South America and Latin America, and there is only installation of equipment in Latin America. There is no technology development made by the countries. We are only importing the technology of the other countries.
Okay. Thanks for your question. I don't know if you can see me because something is happening with the... Okay, thank you very much. Well, as I mentioned, the energy market or the electricity market has different segments. Transmission and distribution are monopolies, and particularly the generation market is a competitive market, okay? And in our region, the relationship between state and market are very sensitive. So if your project is not competitive in terms of the competition, obviously, will not award the action or will not compete in the market. So, for example, one good example of this is that the CSP technology, that is a very good technology in order that it can generate more power and with more reliability and in a clean way. So if you ask me if Latin America has CSP technology, I just can say I just know about one CSP solar farm in Chile of around 200 megawatt of capacity in the north of Chile, where there are a lot of radiation. And this project started construction in 2013 and just start operation in 2020 with a lot of issues of financing, especially. So the space for technology is a role of the state, and the state and market today, the relationship is very sensitive, and I think that the role of the state to create different subsidies or different regulation or mechanism in order to incorporate technologies or new technologies in our matrix. Personally, I think that CSP is a great technology, and the governments have to work in the new regulations or new policies in order that can incorporate this kind of fantastic and good technology in our electroenergetic matrix.
Thank you so much. Professor Iniyan, there is a question to you. Can India industry produce solar collectors?
Yeah, and we manufacture a lot of the flat plate collectors for water heating system, and mainly the flat plate collectors and the curved glasses. And normally it is being imported from European countries because it has very good smooth finish and it gives better efficiency. And so the collectors, mainly the flat plate, of course, India is manufacturing, not the other collectors.
Thank you so much. Ms. Aniella, it's concerning Latin America, I think it's driven to you. What will be the impact of climate change on the expansion of solar power generation across Latin America?
Well, we are talking when we are talking about climate change, we not also are talking about energy. Okay, we are talking about extreme weather events. So and also droughts and also hurricanes and different points. So the role of solar energy is regarding to the emissions, and we know that we have to limit our temperature in 1.5 degrees globally. So I think not only because of climate change, because of the sustainability, that we have to incorporate renewable energies in general, and we have to have more preoccupation about this issue. So I think that solar power, we have a lot of technology, we have a lot of knowledge, we have a very good radiation. We have to continue working in boost this kind of technologies, and not only because of climate change, because other point, very important point regarding to the sustainability or 17 sustainability development goals.
Thank you. I have a last question, but this question is going to the organization of the event. If the presentation will be available for the public, someone can answer?
Yes, not the slides, but we are recording the whole presentation, and this will be available for those who are following the webinar, so you can check the records afterwards.
Thank you so much, Professor Amaro. Unfortunately, we reached to the end of our solar session with the brilliant contribution of Professor Iniyan and the consultant Aniella Descalzi. For sure, this contact was only the first one of many promising future opportunities. I invite everyone to feel free to start dialogue with the experts, add them to your networks. Once again, our thanks to come to this audience. All of you, we are very important to make this session reach to its goals. Being a play and guide the conversation and orientation for the common interests. I would like to wish a good afternoon to everyone and have an excellent event in the afternoon, in the rest of the day. Thank you for the organization. Isaac, thank you so much for your support. Bye to everybody.
Thank you.
Thank you.